and welcome to the Wood Carbon Seminars. This is the follow-up discussion session to the second presentation in the webinar series called LCA and Wood. My name is Monica Huang, and I work for the Carbon Leadership Forum. I'm the one who's keeping things organized for these webinars, and I'm going to go over some introductory logistics before we start. Here is the agenda for today on the next slide. I'll go over logistics, the quick disclaimer, an introduction to the Carbon Leadership Forum, and an introduction to the Wood Carbon Seminars project, and then I'll pass it on to Kate for the discussion. First of all, this webinar is being recorded and we'll publish the recording online. All attendees should be muted. I'm hearing some noise, so please make sure that you're muted. Do not unmute yourself unless you're a speaker. Don't share your screen. And don't share your webcam. So please check those on your Zoom interface. By popular demand, there is no chat discussion today. Instead, if you type something into the chat box, it will go only to Kate, who will ignore it because she's moderating the discussion. So if you have questions for the speaker, you can type them into the chat box, and we will review the chat log after the webinar and collect questions that way. There is no survey this week since we will collect questions via the chat log. All right, this next slide is just our disclaimer slide. And then the next slide is about us, the Carbon Leadership Forum. The Carbon Leadership Forum is a nonprofit industry academic collaborative at the University of Washington. We are architects, engineers, contractors, materials suppliers, building owners, and policymakers who work collaboratively, pioneering research, creating resources, and incubating member-led initiatives for greatest collective impact. Our goal is to accelerate transformation of the building sector to radically reduce and ultimately eliminate the embodied carbon in building materials and construction. This next slide shows that we have an active online community with various focus groups on different topics with over 1,000 members and growing. And this next slide shows our sponsors, so thank you to the Carbon Leadership Forum sponsors. And now I'll talk about the Wood Carbon Seminars. The Wood Carbon Seminars project is supporting the Embodied Carbon Construction Calculator project, also known as the EC3 tool. This slide shows the schedule for the seminars and all the topics we have in the series. Today we are in the second session, the orange row. LCA and Wood, the discussion portion. And I'll talk quickly about our discussion session format. Last week we decided on a new system for addressing questions and how to structure the discussion. We want to be able to get an answer for all the questions submitted by the audience, but we also want to answer some questions for the EC3 tool and help the EC3 tool move forward, since this project is kind of part of the EC3 tool. So for the discussion sessions with the speakers, Kate is going to focus on key questions related to the EC3 project. These key questions are probably popular topics for everybody, so we hope you'll find them valuable. As for questions submitted by the audience, we're working on getting answers to them kind of behind the scenes, offline. There are hundreds of questions, so it's going to take a while, but we hope to address as many questions as possible and publish the Q&A online after the end of the webinar series. So that's the plan for the questions for right now. And without further ado, I'll pass it on to Kate.
Okay, hi, thank you, Monica. Today, I wanted to start and frame the discussion or reframe the discussion before I ask our presenters to join. So I want to remind everybody that we're working in this project focusing on how do we take data related to wood products and integrate it into decision-making as a building sector. And we're doing it at the stage of optimizing procurement. So we're looking to say, at the time of it, I know I'm going to buy a specific material, so I'm going to buy steel or I'm going to buy a glue laminated beam. How do I make a choice to make the carbon smart options between those different options? So we're really looking to try and understand how to take data that's in environmental product declarations and use it to incentivize low carbon material solutions across the sector. And in this section here, we're talking about wood products in specific. But if you're, the EC3 tool is an open access tool, so anybody is able to access it. If we look in and dive in how we're looking at the use of the tool, we're reporting the results of the EPD for all the products within a specific category, and then we're looking at the EPD itself from a specific product, and we're trying to understand the precision in that result, as well as how it compares to other products in that product category. So when we're looking in the EC3 tool, we're sorting materials within the same search category. So that's one of the first criteria, is that we're not sorting different things. We're not going to compare a steel beam to a wood beam, nor even a piece of plywood to a piece of a glue laminated beam. In the tool, we have pilot versions of a baseline, so estimates of what might be the high embodied carbon of a product, and then an estimate of the variation and uncertainty within EPDs, as all EPDs are known to not be precise, but rather are estimates. And we're using what we're calling the benefit of the doubt methodology, in which we're, in every category, we're assuming a high variation unless there's very specific data. So an example of less specific data is an industry average EPD. Higher specific data would be one that was a manufacturer-specific EPD, and for a very specific product, and ideally had data that went all the way up the supply chain, that was supply chain specific. So I'm going to, before I go to the other slides, I'm going to stop the slide share here, and I'm going to invite James, Elaine, and Reid to join in here. And unmute themselves, and let's see, I'm unmuting you, or are you all able to join in? I see James.
So you want the video as well?
Yes, we're having a friendly discussion here. This is the goal. So we're having a chat here, and we're welcoming in people to hear our chat. I want to start again emphasizing that we're looking to answer some questions specifically about how we should be representing wood data in the EC3 tool coming from EPDs. And that makes me want to start here with some questions for James that came up from last time, especially related to how the new EPD data is going to be reported out with more detail than the previous EPDs. So you talked a little bit about this biogenic carbon results within the EPD, James, and I want to make sure I'm understanding what's in here and what's not in here. So when you say biogenic carbon emissions from product, can you describe what's in that?
Sure. And yeah, thanks for bringing this back up, Kate. I know we covered a lot of ground very quickly in the last call. So yeah, I had to kind of blast through this part of the presentation. So under, the key takeaway of this table is that it balances, that there's a net zero. And that is a specific requirement from ISO, such that a cradle-to-gate LCA or EPD can never show a net biogenic carbon storage without accounting for the end of life. So what's considered under this biogenic carbon emission from product is two components. The first is an ACE3, which is product manufacturing. So this is all the biogenic carbon that is, it's essentially leaving the system boundary as co-product and waste. So that's accounted as a direct emission, even though, for instance, we know that the co-products are not directly converted back to atmospheric CO2 instantaneously. The second component.
Can I ask a question there? So I got a round log, and I bring it into the facility, and I start cutting it up, and I make a bunch of sawdust and things like that, and wood chips and stuff. That's what you count as the byproduct. Is that correct?
That's right.
And so that in this 1025, some of that is the carbon that's in those that wood chips and sawdust.
Yep, exactly.
Even though it's not burnt.
Yes, exactly. The portion that is burned is under that last row item there. That's actually separated out because that is a direct emission in that A3 phase, that 184.8. That is actually the amount of biomass from within the system that's burned, for instance, within firing the kiln. So,
okay, so
that
this 184 is
go ahead.
This 184 is just the burning in the kiln. This is the
Correct.
burn CO2 that's emitted in the burning. When you burn, you also release other emissions like methane and other stuff, right?
Yep. Yes, exactly. And those emissions leave essentially the biogenic portion of the accounting, and those actually enter the anthropogenic, which is they are originating from a fossil source, but those are characterized by the IPCC forcing factor. So, for instance, if there's methane emitted from biomass combustion in the drying process, that is characterized by a factor of 25, which is the exact same factor that for any other emission that came from a fossil source. It becomes irrelevant whether or not it came originally from a biogenic source, because it's an anthropogenic process that caused it to be emitted as methane.
Okay, so this is only the CO2, not CO2e, only the CO2 that's emitted in this burning. And this
Yep.
biogenic carbon, this is the physical, this one up here is just the actual physical carbon that goes somewhere.
Yep, exactly. That is the carbon that is stored in the co-products and the waste.
Okay. And then down here, the C3, C4, this 843.66, that is,
right.
That is the amount that's still hanging out in the landfill, not rotten?
No, that C3, C4 in a cradle-to-gate EPD, reporting it there serves a dual purpose. First and foremost, this is the CO2 equivalent of the biogenic carbon that's stored in the product at the manufacturing gate. So by accounting for it in C3, C4, you do two things. One, you separate it so that if you were to pick up this cradle-to-gate LCA and you'd want to do a cradle-to-grave LCA, you know exactly where your starting point is. You know that I've got 843 kilogram CO2 equivalent that's entering that end-of-life phase. So even though C3 and C4 are not declared in a cradle-to-gate EPD, it's accounted under that bucket. And the reason that it's accounted as an emission and not just, let's say, as an additional technical scenario information is so specifically so that this carbon this ledger here balances. So it's accounted as an emission, even though we know that it's not emitted directly, and it's certainly not 100% emitted. Portion of it is stored long-term, et cetera. But it is accounted there as an emission, so that essentially it's a conservative way to account for the biogenic carbon that has an unknown fate in a cradle-to-gate EPD.
So you put it into the C3, C4, but when you do it in a whole building LCA, you wouldn't report this as the amount emitted, would you?
No, correct. That is the amount that enters that landfill process. So, I do have some more slides if you'd like to show them, but this, essentially this carbon dioxide equivalent then enters the landfill, at which point a portion of it is decayed. So that's this first portion here in the landfill. Of the landfill gas that's emitted, a portion of that, and that landfill gas I should mention is roughly 50% CO2, 50% methane. Of that landfill gas that's generated, a significant portion in a typical landfill is captured in landfill gas capture, and that's that second part there. And a significant portion of that is then actually burned for energy recovery, which then feeds into the electricity supply grid, et cetera. A smaller portion of it is actually flared without energy recovery. So in that case, they're simply flaring the methane because it's known that methane is a pretty potent greenhouse gas, all things considered. So regardless of whether it's captured as energy, there is the desire to oxidize that methane. So the end-of-life accounting for a wood product, if you were to extend the accounting to cradle to grave, would account for the methane that's emitted directly from the landfill gas. It would account for the CO2 portion of that landfill gas that's emitted directly. It would also account for the CO2 for all of the oxidized landfill gas, whether it's captured as energy or not. And if you were to extend, let's say, your whole building LCA to include Module D, then the portion of that landfill gas that's combusted with energy recovery would also show a CO2 removal, or actually a number of greenhouse gas removals from the substituted energy, let's say if it feeds onto an electricity grid or is used as a fuel otherwise.
So if I go back to here, where is the negative that often shows up? Is it this biogenic carbon removal from product, this negative 2,000 right here, that when we look at in some EPDs are negative. Old ones, from Europe show a negative number. Is it this number here?
Right. So what you'll get if you were to do a cradle to grave EPD is you have the amount of biogenic carbon entering the product system in this module A1. You'd have the same accounting in A2, A3, but then what happens in the C3, C4, because we know that biogenic carbon or the wood doesn't decay completely in a landfill, a portion of that is stored permanently, in fact, a significant portion, that essentially in that case, the negatives that enter in A1, because you were actually counting for the long-term fate of that, did not completely cancel out. You'll have an emission in C3, C4 that's less than 843. So now when you do your balance of a whole cradle to grave, you're getting a net negative under that.
So Elaine, you've done a lot of work with EPDs. Do you have some, are you concurring with what James says here, or do you have anything you want to add?
You never argue with James. He's an engineer. You'll lose. That's just the best way to describe it. No, I think he's done a really, really good job. It's important to realize that the EPDs you're seeing now are not going, that was under the old PCR, and the new PCR, which is what the new EPDs that are out imminently, I don't know, James probably has a better timeline than I, will have this kind of framework, which really talks about that whole, it doesn't address the whole life cycle because we're only going cradle to grave, but it does address and make sure that balances so that we know that ultimately those products at 843 now sits in the designer's lap of how am I going to be most efficient in using this material? How do I extend its life? How do I figure out how to repurpose and reuse? I'm going to just make a plug again for the work that we did this spring. We hosted a circular economy workshop looking at how you think about wood in the circular economy. All that stuff is available on our website, but it really took on this, how do we keep it out of the atmosphere longer? If we're growing this stuff and we're doing either a good job or an excellent job or not such a good job, but we put it in products, how do we keep it there for the longest possible time? What are the levers that we use there? And so that 843 gets to be what the AEC community, I guess is what you call it, get to play with in order to do their part in reducing the impact of carbon dioxide in the atmosphere. That's kind of what I want to say.
And I want to be really clear. Thank you. And just to be really clear, this is only tracking the biogenic carbon that's physically in the round log that arrives at the sawmill. And any other biogenic accounting is outside of this system boundary in the CPD at this point, right? It doesn't track
no, not exactly. No, that's not exactly correct, because inside that 2,000, that's the amount that's in that product. But remember what it took to get to that product. You know, when people look at it, an EPD, they'll see all the manufacturing emissions and all that roll up of emissions that it took to make that product. But there was also all the stuff that it took to grow the tree. And that's included in this full accounting in terms of the emissions that it takes to actually create that product. So yes, it's measuring that log, but it's taking into account the fact that, you know, it took energy to plant the seed, grow the seedling, you know, go out and plant the seedling, do the site prep, do any kind of treatments, do any kind of harvest, all that sort of stuff is included in there in that emission. So just to be clear that this is your starting point. You're starting with this log, but that log has been accumulating carbon for, I don't know, 35 years, 40 years, 50 years, 70 years. Depends on your how long that forest grows before it's harvested.
But it does, like if I burn slash, the emissions from burning the slash show up here. Is that correct?
If you burn slash, that's outside of this system boundary, but keep in mind that the carbon in the slash that you burned is also outside the boundary. So if you're going to bring one in, you got to bring them both in. And it fundamentally doesn't really change the outcome. Both numbers are bigger. And because when you burn slash, you still have leftover carbon, it actually, you end up with having to account for that decay on the landing as well as the C3, C4 accounting of whatever went into the product.
So that, I mean, that's sort of where I'm saying we are not, this is not including those external carbon balance of the forest. This is really just reporting the parts that took place in the emissions from the harvest and taking it out.
Right. It picks up where the forest inventory cuts off. So everything that is remaining in the forest is accounted for in the forest inventory.
And Reid, does that match with how your understanding of the forest inventory works? Like when
it depends why you're doing it. For an EPD, this is the way you draw the boundaries. Is my understanding. I'm not an LCA expert, but the work I have done is asking broader questions, and for the broader questions, we draw the boundaries differently.
So I'm curious about that. So, because we're sort of, I'm going to jump, I think, to what I was going to be on question 3 then, because I was really intrigued. But I'm going to stop my slideshow because I can find the right slide.
Well, but before we do that, maybe let me answer in a way that might be helpful before we get into something more complex. What happens in the forest, even if you burn slash, that those emissions were offset by removals from the atmosphere in that same forest at some point. So they cancel each other out, I think ultimately is what Elaine was saying. So even if you do extend that box back to the forest, if you're in a sustainable, constant carbon stock world, then any of the emissions from the forest plus the wood you remove are offset by removals of carbon from the atmosphere by that same forest. So mathematically, they cancel each other out.
But that was a big if when you said if we're in this constant carbon world, right? A sustainable world with a constant carbon. If I'm interested in not having it be constant, but having it be an increasing, that's, you know, when you went through these different models of forest accounting, I got really excited about this fourth approach here, where it talked about what would have happened if we let the tree grow, because that comes down to the question that's sort of nagging at owners and architects and engineers of trying to understand what is the consequence of changing our practices. Can we change practices and have a positive outcome come from that? So, you know, I guess I would like to jump a little bit into your more complicated slides, because when you talk about, you know, the impact of change in forest management, or how do we do this accounting, I'm curious to understand, you know, how could we get better data around what are the changes in practice, and how do they result in carbon optimized solutions?
I'll take a stab at it. First, let me explain that the reason that I added a counterfactual to the approach 2 that we had talked about simply was because it fit more easily on the slide than adding a counterfactual to any of the other approaches we were using. And in fact, well, we talked about this before, you draw a system boundary, but you also add a counterfactual forest that represents the tree that would have continued to grow.
So I'm going to be a little bit dumb here. Could you describe what you mean by counterfactual?
Yeah, that's a good question. Maybe I should say an alternative scenario. That might make more sense to people. It's an alternative scenario where you didn't make the wood product and the forest continued to grow. So that's probably us jargony. I'm glad you asked.
Okay.
Now, there are a lot of good reasons why EPDs don't use counterfactuals. You know, they try to be attributional. They try to tell you what it is, what are the attributes of the product you're buying. And when you start rolling in attributionals and future modeling and things, the uncertainties explode, number one. And just think of all the opportunities for mischief that you introduce. You know, if you let me develop the counterfactual for you, I can get you any answer you want from any analysis. So if you want data that's believable, less dependent on assumptions, less easily manipulated, it's good to stay away from counterfactuals, or at least be very specific about what they're going to be. What I would like to do, though, in talking about counterfactuals is not look at them in approach 2, because this is kind of a constrained spatial analysis, and to do any of these things on a small spatial scale, you almost have to ignore the role of economics. And I hope folks were listening at the end of my presentation the other day when I said that you ignore market effects at your peril. There's just so much work out there that has said that you can get just the absolute wrong answer if you try to determine carbon impacts without looking at market impacts and how landowners respond. So could we go to that other slide that I prepared this morning that also looks at counterfactual? Now you see why I used approach 2 instead of approach 3 when I tried to make this. A little harder to read, but on top what we have is approach 3 from before. We're looking at the entire supply area, but we're going to look at it on an ongoing basis. You know, we're going to produce so many tons a year of a product over some period of time. And over that period of time, in our system that we're operating, we have a net flux of carbon in and out of the system, just like we did before. Now, the question we're going to ask is, if we hadn't done that harvesting, if we hadn't used that wood, what would have happened to that forest over the same period of time? To be accurate and to get, frankly, believable results, I feel you need to be very careful when you do this. You need to choose your counterfactual system very carefully. You need to look at things like, how are natural disturbances going to be different in this forest as a result of this being left to go to some old age where it's not being managed carefully anymore? Again, what are responses if this reflects a lack of a market? How much of this land are you going to lose that otherwise would have stayed in forest? And just generally, how do market effects impact all of this? This is not impossible to do. People do it all of the time in the context of looking at the impacts, especially of different policies or different market forces. And what you do is then you compare these two systems. Basically, the difference between the two systems gives you the net effect. Now, if we can go to this, well, where is it? It's, let's see, is it slide 33?
No.
Oh, I don't think we have it.
I might not have, I didn't have all of them in here because I was
Okay.
Getting lost.
Yeah. Okay. Well, it was just a slide, one slide that a colleague of ours had prepared from Forest Service data that looked at market effects associated with increase in wood demand. I showed you this one the other day, but I decided it's not very helpful because it looks at such a narrow range of wood products and one that we really don't, it's a very small fraction of the total demand. We don't really know how it'll evolve. So I substituted that some work by the U.S. Forest Service that looked at wood demand more generally and the impacts of larger and smaller increases in demand over time. And what it showed you was that you get a change in forest area that is just too large to ignore. Every study I'm aware of shows that with increased demand, you get increased area in forest. Now, it's not an easy thing to devolve back into a simple statement about an individual product, but it's, again, I think you ignore it at your peril. The carbon impacts of these, you see one here in the case of pellets. In this study, it showed carbon stocks actually increasing compared to the demand not increasing. That was the black dots that we're comparing again. The left-hand side was without increased demand. The right-hand side is with increased demand. And in 2060 or 2040, we have more carbon in the forest in this case. There are other studies.
There's more.
I'm sorry?
And it's not, and it's the change that's the important thing that we're looking at here, right? That it's increasing, because over time that means more carbon has been removed.
Oh, this is in the forest. Yeah, we've removed more from the forest, and at the end of this period, we have more in the forest remaining. Now, if you look at that dotted black line, we talked about it before, in about 2025, you have a transitional period where, because of your increased harvesting due to the increased demand, your carbon stocks on the right, the dashed black line, are lower than they would have been on the right if you hadn't introduced that demand. So time is important. What's also important are the specifics, the type of product, the area it occurs. That study of pellets was specific to the US Southeast. But there are a lot of these studies out there, and EPA does them, NC State, Ohio State, Oregon State, Texas A&M, models ranging from FASM to the Forest Service models to the Global Timber model to, the folks on the phone here could probably name off a half a dozen more. But there are people that have integrated this analysis of market effects and carbon biophysics in a way that gives you some important insights into what happens when wood demand goes up or down. Now that, in my view, the way to use this is as another tool, another piece of information. LCA is one tool, EPDs are a tool. I think using any one of these as a substitute for a decision is wrong and potentially give you the wrong result if you use any of these in isolation. So what I encourage people to do is to look at the information you get from all of them, and never forget to include some of these that take a look at the impacts of markets on forest stocks and fluxes over time.
And okay, so what I heard you say is that some of the consequential LCA models, or that are looking at alternative scenarios. When you look at alternative scenarios, there's actually many different alternative scenarios that should be looked at, because they are uncertain of which scenario will take place. So there's a range of different scenarios that might happen, and we're trying to identify which scenarios we want to incentivize. Like which are the most, from a global climate perspective, which drive towards lower carbon, or more carbon being removed from the atmosphere. So if you're, when we're talking about a building owner, or a city or a state, or something that is purchasing material, how is there ways for there to get data that can help us make this carbon decision? Or are you saying that we have to do this in something other than LCA? So I guess that's, we're looking to try and say, can we do something more sophisticated than assume carbon neutrality, so that we're incentivizing purchasing of wood that is in this carbon positive way. So is there a way that we could collect the data? Like this is that we know what kind of data could we help generate or collect?
The issue is that I think at the scale you're talking about doing this, you just don't have the data. The data the Forest Service use, EPA, all these researchers is at regional scales at a minimum, because that's a scale over which these markets operate. So to try to do this at an individual landowner or individual piece of wood level just isn't realistic. So again, what I think what you could do is look at some of the work that's been done at the regional or national scale, see how market forces react to changes in demand and how that reflects in carbon, and use that to inform the results you get from other kinds of tools that don't give you that information.
So Reid, here's a question. How the forests are managed will impact this, as well as how the market, both of those things impact, is that correct?
Yeah, and they interact, absolutely.
And so we're consumers, so we're part of that market. So
yep.
We're interested in seeing how we can be as a market driver. Could we change our behavior that might shift the market? I mean, that's what we're asking. Can we pick organic, or and how could we do that with wood products so that we help be transform what the market is asking for, so that the market is a stronger driver towards climate smart solutions?
Let me answer that in the context of something you said earlier, which is that what you're really trying to do is differentiate between producers of OSB. And the work I have seen would indicate strongly that any differences in forest management and that you'd be able to discern looking at things that are that close in wood consumption and manufacturing processes in a country where it's all produced under sustainable management programs, you're just not going to find much of an effect there. The differences are going to be very small. And what I would focus on would be the stuff you get in the EPD. I think the significant differences, if you're comparing OSB to OSB, are going to be related to fossil fuel consumption and things like that.
And probably your grid energy, which varies from region to region because of what's in the grid. You know, in the West Coast, we have lots of hydro. In the East Coast, you don't have hydro. You might have some nuclear power. Or you have a lot of coal generation. So those things I think matter. But I want to just step back a little bit from this because, you know, Reid, I want to put a finer point on one of the things that Reid said, and that's that you can't separate what's happening in the forest from what's happening in the market. And if you look at that data that I presented the other day that looked at, so that was forest inventory analysis data for the whole US, all the regions sort of broken out. And you could see, and I think you included in your slide deck, if you want to scroll down, Kate, it's number 34. Go to number 34. Yeah. So if you look at that and you say, how do I incentivize doing more carbon accumulation? And you look at the fact that the places that are accumulating carbon are the major wood producing regions for a lot of different reasons. One, there's an incentive to grow more wood and to grow it more efficiently because there's a market and you can make money at it. And then the corollary of that is that they're in regions where there are no markets, like that one that's showing that complete tanking of the growing stock. There are no markets in that region, those regions. Almost, you know, there's a very small corner of the inlet.
They clearly build out of wood. So why is there no market? That's the question. Why is there no market? Because they're importing wood.
There is no market because there are no mills, and there are no mills because most of that area is federal land, and even though it's counted as timberland, or it wouldn't be in this chart, It's essentially off limits to harvest. And so because you lost all the mills, you know, somebody was talking about Colorado earlier, you know, in Colorado, you see this absolute tanking of the growing stock because of all the bark beetles and the wildfires and all the rest of that stuff. Even if you wanted to do something there are no mills. So how are you going to do it? You're not. And so the importance of focusing on regions where there are existing milling infrastructure and put that demand there. If somebody said, well, you know, I want to focus on having wood that really addresses this forest health crisis, then you're going to focus on those areas. What you are going to see, interestingly enough, is a reduction in the carbon stored in the forest because of increased demand. But you're also the offset of that, which is way out in that D category you were talking about, is that these kind of impacts won't be as apparent because of the interaction between fire and forest density. So, you know, that's a whole other discussion. But when I think,
so I want to cycle it back to the EC3 tool and differentiating between products, because I want to make sure we get there. So I thank you, Elaine. I do think it's so I want to come out of the forest and back into the products, because we talk about what are the causes of variation. So you talked about electrical grid. I don't think electricity is a major demand. I mean, how much electricity is actually used in wood product manufacturing? Isn't it mostly natural gas versus biomass in terms of energy processes? James, do you have a sense of that?
I mean, it's both. You know, the primary energy source at a mill for the equipment is electricity, and then the drying energy is going to be either natural gas kiln or a biomass kiln.
Yeah, it's relatively unusual for a sawmill to have a cogeneration unit where they make electricity on site. So most of them are purchasing electricity.
Okay, and so the electricity is running the engines and things like that, and the natural gas and the biomass are the heat to dry the wood?
Yep.
Is that, and do you have a sense of the relative proportion of the global warming potential of wood manufacturing? Because I think Elaine showed, you had a slide that had the total breakdown here, right?
No,
This is...
No, hang on. That is just the forest.
Okay, then never mind. I go back away. Take that one away. So, you know, but we had, you know, when we looked at the raw material production and product manufacture in the LCA EPDs for wood products, most of the emissions come in this product manufacture stage. It was, you know, like 80% of the impacts are there.
80 to
right.
90.
Is that?
Yep.
Check. Is that correct, James?
Yeah, in that range for sure.
And so, in that's broken out for, so the major emissions that are taking place from wood manufacturing are electricity, natural gas, and biomass burning. And the levers that somebody could have is make their plant more efficient, get cleaner electricity, or get a cleaner drying process. Is there, you know, could they skip the drying? Like, could we specify lumber that, and could we accept craft lumber, and then that could save drying energy?
That is probably a topic more in the architectural design purview than myself. Not really clear on that, but certainly it would, you know, removing the drying portion of it would certainly lower the impact.
But you can get a stable product though, Kate. That's why they dry it. I mean,
but you can also, you can dry it. You can
with absolute junk.
Yeah. So I'm just trying. I'm looking at what levers there are, right? So if we just use a rough a log that's not dried and or cut, you know, if you just took a tree and used it, it has relatively low emissions because we haven't done anything to it. The more we do to it, those are the, I mean, and we want those things. So I'm just trying to understand what are the drivers there. So if I were choosing between manufacturers, they might be able, or I'm looking to incentivize lower carbon manufacturing processes, it's about those fuel sources. There's not a chemical reaction that's taking place or something in that.
Okay, I want to just back up a little bit. I mean, what we have seen in the forest sector in the last, even in the last 2 decades, but definitely in the last 4 decades, is you've seen this change from a lot of little small sort of mom and pop mills that weren't very efficient, and so it took a lot more energy to generate something. They had a lot more waste, and we've moved more and more to consolidating to these fairly enormous, highly sophisticated plants. And so your number of what you would use are changing by the year. What we saw from the initial surveys and work that we did that was published in 2005 was pre-recession. When we went back and resurveyed, we saw a whole bunch of different changes because all those little players went away. So now you're focused on these highly efficient mills that are cutting within, a millimeter of a millimeter in terms of their saw curve. They're far less waste, far more efficiency, and they're based on, a whole bunch of, if you want to think about computer assisted design, computers have hit the milling infrastructure. So they take that log, they scan it, they know exactly where the defect is, they cut around it, they maximize the value and the volume. And so when you think about levers, you think about maybe the lever is, let's pick the most efficient mill that I can, or the one that's the most sophisticated, so I get the most product out of a log. That might be another way to think about that, but that's the way the industry is going anyway, just by virtue of economics. 2007 or 8, when everybody had a recession, the wood industry had a depression. They were just absolutely hammered.
If I could add, Elaine, and those differences in efficiencies are probably going to show up in the EPD because, if you're using the wood more efficiently, you're probably producing more product with the same amount of fuel or whatever. So you'd be spreading those emissions out over a larger amount of product.
The stuff we just let me just add one more thing so people understand this too. The footprint of the updated work that we published in 2017-18 actually had higher footprints, and we kept looking at it, like, why are there higher footprints here? And part of it is that we had done a better job of data collection. There was more data, there was more information. The other part of it is that in that intervening 10-year period, there was something called the MACT rule that required a whole bunch more emission control devices. And the emission control devices, I don't know if people know this on their cars, you put emission control devices on it, reduces the amount of energy that's actually useful because you're using some energy to run these emission control devices. So the footprint went up, but the hazardous air pollutants went down. That was the whole idea. So now you got this trade-off, and that's really what the LCA and the EPD is talking about. So when you think about making those choices and think about where are the places where I have these very efficient milling infrastructure, those are typically also the places where you have a very efficient forestry, high intensity management kind of structure, and say those are the kinds of places that are going to give me the lowest carbon footprint wood, assuming that the inventory that they're drawing from is neutral or stable, which is why we have 21930 in the PCR now. I don't know if that's helpful, but I'll pause there.
No, okay. Well, I want to make sure we get through a couple of the other things here. So I think we talked about, that was looking at what are the variations between manufacturing processes. So we talked a little bit about the challenges of modeling the variation in the forest. So that I know the level of questions that's where a lot of people are driving to. Right now I'm just going to the product. So we looked at the manufacturing process. The EC3 tool right now does not include transportation. And in many high carbon impact materials, the transportation impacts are less than 5% of a total impact, and that they're somewhat equivalent. I'm wondering, with wood products, is the buying local more of an important issue of the total carbon footprint of the product relative to in choices? So I mean, I guess I'm thinking, James, you've got a data related to how that's integrated into whole building LCAs, which are including those stages. Is the inclusion of transportation really important in wood product selection? Or how important is it?
I would say, in a relative sense, relative to the overall impacts of, let's say, a stick of lumber, which are somewhat low overall, in that sense, it is potentially a higher proportion, but, it really depends on the distance and the method of transportation. The economics are really driving the fact that if you are going to be shipping, let's say, a wood product a long distance, it's going to end up on a train in a distribution center that way. So I would say that, probably roughly comparable with other materials in terms of transportation, let's say, from the mill to the construction site.
So is there, I mean, I guess, is the, let's see, I'm buying a CLT panel from Austria versus BC, and I'm in Los Angeles. I mean, that might be an issue. That might be a difference.
Yeah, and I mean, certainly, if you get into mass timber, then, certainly that becomes more of an issue. But I would say, too, that if you're shipping it from Austria, it's, very likely going on, ocean freight, which is, because of the economics of the situation, it's very efficient per ton of material moved per kilometer. So, you're not going to have someone shipping a 2x4 on a truck all the way across the country. You're going to have, it's going to go on a train or some more efficient distribution system, which, relative to, the carbon footprint has a similar effect. That fuel isn't cheap, and, well, I guess it is now, but, you're going to get the economic drivers into a more efficient distribution method.
So I think we're really getting close to the end of the time. I know that, so I really appreciate getting input from you guys. I think it's going to be really interesting to see how the data that's coming out in the new EPDs, I'm excited to see that and learn from that and figure out how to best take that data, the more granular data that comes out of the EPDs, and integrate that into our design decision making. So I'm looking forward to continued discussions on that front. And I know there's a continued hunger for understanding how we can get the data of carbon smart forestry. What I'm hearing from Elaine and Reid is that there are that the challenges of getting that data are not insignificant, and that the uncertainty of the modeling of different options is challenging. So we're going to continue to go. I guess before we end, if you were a last question, if you were giving advice to an architect or an owner about how to pick a lower carbon wood product, what would you suggest? James.
Yeah, I would echo Reid and Elaine's comments previously, that you're going to want to, specify wood if possible. If you have, I understand that in the wood products industry, the distribution channel is such.
I don't want to choose wood. I want to choose between wood. How would you choose a carbon smart wood once you already know your?
Well, I'm just saying that it's not always possible. By the time let's say you go pick up wood at Home Depot, it's not necessarily you're not getting a label necessarily that has the mill and the efficiency of that mill. So it becomes a very difficult question. But, if you were to have that information available to you, I think your best bet is, an efficient mill that's employing the best technology, and you know, as Elaine said too, that may imply that there's a little bit higher carbon footprint because you have trade-offs in the other parts of the life cycle. So yeah, carbon is important, but you know, from a consumer perspective, I think you're going to want to look at the EPDs themselves and understand, you know, the whole range of impact associated with the product.
Thanks. Reid?
I would buy from sources that were getting their wood from sustainable management practices and avoiding deforestation. I would rely on the EPDs. But if I wanted a big picture understanding of what the forest carbon impacts are of producing 500,000 extra tons a year of OSB, I would sit down with Bob Apt at NC State or Brent Sogren or Hyde State or Robert Beach at RTI and have them walk me through what the options were with their modeling frameworks. I mean, they've got the data. So the question is, how do you use those existing modeling frameworks to gain some insights into the questions that you're asking?
Thank you. Elaine?
Well, one of my forestry buddies, he says it's really easy. Grow more wood, use more wood. But that wasn't the question you asked. I would focus on areas that are highly productive, because those areas allow you a lot more flexibility in terms of how long you think you're going to, this product that you're going to put in use, this building you're going to build, how long do you think it's going to last? As long as that building is lasting longer than the rotation age of the place that you're pulling it from, and that you've got those stable carbon stocks, then you're actually getting a bump up in terms of carbon that's removed from the atmosphere. So it's those places that are highly productive and that have that management and sustainability built into the laws, the regulations, whether or not they're certification is certainly a component of that. But by and large in North America, we have laws and regulations that dictate all sorts of things around forests and forestry and forest management that tend to point us in the right direction. Suppose I'm biased, I like North American wood.
Okay, well, thank you all for sharing your knowledge, expertise, and perspective. So really appreciate you being here. Thank you everybody for joining us. I'm going to be shutting down the meeting, but we will hold the chat. So please get your last chats in now, and then thank you everybody and have a great day.